3, 2, 1.
Hello students, so this is me doing the experiment. Hopefully you guys are able to do it at home, but if not, this is what you would see. Come over here, I've already put the ice in here. I've turned the pan on, I've turned the heat on high to do as fast as I can. And if I've noticed, by 31 seconds, the ice has changed from a solid into a liquid water. So that is telling me right now that a solid is a colder temperature. As it gets warmer and warmer and warmer, solids will change into liquids. And now we're going to keep observing this and see what happens. It's still liquid, and we're going to watch it. Meanwhile, let's talk. What do we think will happen? Gam, my camera person, what do you think will happen?
It will turn to ice cream.
She thinks it's going to change into ice cream. I would say there's a 50% chance of that because it is ice, and we do have some cream in the kitchen somewhere. So we're going to keep watching it, and it is still a liquid form. And so at 1 minute and 24 seconds, if you want to write this down, still liquid. Again, this is our observations. What are we seeing happening right now? Still liquid. However, the pan is working. I mean, the ice has clearly changed from one state of matter to another state of matter. So I won't need this second pan. Now we just got to see and wonder, will anything else happen? We could say, hey, you know what, we're done. We found 2 states of matter, but can we get to that 3rd state of matter? I don't know. Maybe we have to go even colder and it'll change from ice to gas. Or maybe we have to go hotter. It changes from water into gas or steam. Let us see. It looks like, ooh, I see something coming up, but it's hard to see. Maybe we do like this. It is too easy. Can you guys see it? It's coming right here. That looks like the water at 2 minutes and 10 seconds, because it's 10 seconds ago. Look, it's bubbling at 2 minutes and 10 seconds. The liquid water is changing into a gas. What is that telling us then? How is temperature connected to the states of matter, especially with water? That means that in its coldest form, the state of matter would be solid. And then if it gets warmer, it turns to liquid. And if it gets even warmer, it turns into a gas. So think about gold. Most gold that we see, is it solid, liquid, or gas? Gam, what do you say?
Ice cream?
Most gold that we see, like Nexus stuff, is in its solid form. So how can we make it into a liquid form? What would we have to do to it? We'd have to make temperature really, really high and it would turn into liquid. Question is with gold, if we'd make it even hotter, would it change into gas like the water is? What we just learned is it goes from solid to liquid to gas as the temperature goes up. Now I wonder if I went backwards, could I change it from a gas to liquid to a solid? I'd have to make things really cold. Unfortunately, I cannot make my kitchen super cold, and so our experiment is done. So we'll say at like 3 minutes and 30 seconds, half the water, liquid water, has changed into gas. Should we wait and see how long it takes for the whole thing to disappear? Who says yes? Who says yes?
I'm waiting for ice cream.
Gam says yes. So we are waiting to see. And again, at my observation, 3 minutes 52 seconds, everything is bubbling, and I feel like things are going to be disappearing soon. Look at this steam. Question is, where does this steam go? Does it get stuck up here? Maybe. Are we breathing it in? How much of this air that we breathe is actually just water? I don't know. This is pretty cool. So this is how states of matter is connected. So we're going to be doing these kinds of experiments over the next 2 or 3 weeks. We're going to try to figure out how are the different states, how are they different. Clearly we just learned that in a solid state, the temperature is colder. In a gas state, it is the hottest. The middle one is a liquid. And it is still bubbling. Maybe we need to go faster. Ooh, look at that, isn't that cool? Like all the bubbles stay together. What if I should like touch it and see how hot? Should I touch it? Do you think it's really hot? Oh, and the question is, at what temperature does this water boil? You should all learn that from Brain Pop. It's either 0 degrees or 100 degrees Celsius. What do you guys say? Yeah, what do you say?
500.
She says 100 degrees Fahrenheit. She's wrong. It's 100 degrees Celsius. What temperature does water freeze? Gam?
0.
0 degrees, yes. So we know right now this is hotter than 100 degrees Celsius. How do we check it? By boiling water. Should we check with our hand? Yeah, that would be called dangerous. Or In Korea, it's called Weehan, which means dangerous in Korean. Hey, we just learned a new language. So back to this. It's almost all done. And it is at 5 minutes and 30 seconds. I'm going to guess by the 6-minute mark that all the water will be gone. If it's not, I'm going to pour it out to prove I'm right. Looks like just bubbles left, huh? Do you know why there's bubbles? Because water is made from H2O, which is oxygen, and hydrogen, which are actually gases when they break apart. Isn't this cool? There's just one giant bubbles left. 5:58, 59. Again, this goes in our observation. So there is still a little bit of water left. Oh, we're killing the water. He's like, run away, it's so hot. Right there, stay there. Don't move. Good water bottle, bad water bottle. Right there. Ooh, this is like a game. If you guys have a pan right now, can you guys see if you can keep it in the middle just like I'm doing amazingly? Look at that. Look at that. After this, I'll let Gam play. After it disappears.
This is how pure the ice is.
Thank you, Miss Ice Cream. Oh, what's happening now? And my observation is that it took 6 minutes and 51 seconds for the water to go from ice to liquid to all gas. That's our observation. So now you should fill out the conclusion. What is the conclusion? What do we learn? You say, I believe, or I conclude, my conclusion is, or I learned that when the temperature is very cold, that is when the water is in solid form. To go from a solid to a liquid to a gas, what do we have to do to the temperature? And in which state of matter is the temperature the hottest, the highest? That's what you should put in your conclusion. The conclusion is, what did you learn from this experiment? And then can we apply it to other things, like to gold, like I said? Can we change gold from solid to liquid to gas? Yes, just apply what we learned from here. So in your conclusion, what did you learn? What can we apply from this to everything else? That is our experiment. Thanks for paying attention. Long one, and bye-bye.